We saw EIGRP supports only MD5 authentication. And also we have to create a keychain in order to enable authentication. We got 3 routers here and we see that there are adjacencies already with the neighbor router 2. This is router 2's address. This is router 1 or 3's address. I'm in router 1. Router 1, C2 neighbor, show IP EIGRP neighbor, which means everything is fine with them. Meaning if authentication is enabled, they are already authenticated. To know whether the authentication enabled or not, you go to the interface, you'll find it show run interface G3/0. These are the 2 commands. The keychain name is C1. MD5 authentication is enabled. I want to delete this and do it one more time. Interface gig 3/0. No. No. Done. I also want to remove EIGRP. Router EIGRP 10. This is one way of removing a routing protocol. Show IP protocol. There is no routing protocol now. The easy way is if you have more than one routing protocol, this is how you should do. Right now, before removing, let me show you show IP protocol. You have EIGRP protocol. To easily remove all the routing protocols running on a router, we say no IP routing. This removes the routing capability from this device. As a result, all the routing protocol will get disabled. Now put the routing feature back and it will be now a default routing, meaning you don't have any protocol now. Show IP protocol, there is no protocol. But under the interface, show run interface G3/0. It is good to come and verify whether it is completely removed. Yes, it is removed. Because some routing protocol, the configurations that we make on the interface may not get removed. But EIGRP has removed everything. When I remove the protocol globally, all the protocol related configurations are disappeared. Let's do one more router. If you see here, show run interface G3/0, you got some authentication. And also when I type show IP protocol, you see EIGRP. To remove all this in one go, it's very simple. No IP routing. See how friendly is this command. As a result, everything is gone, you see. Gone, even under the interface, it's gone. But good to verify under the interface. So authentication related stuff also got removed when I remove routing feature. And I put back the routing feature because I want the router. But in R1, you remember we have to do the removal again one more interface G4/0 because we did not use the method no IP routing. We went under the interface and we removed those 2 lines. So the best way is just put no IP routing instead of doing like this. Because we did like this, you will still have this one configuration on G4/0. So you have to go to, okay, gone. I think I removed it. What about 3/0? Nice. So what you have learned is how to remove routing protocol and its related features that is configured on interfaces in a simple way. No IP routing. And then put back IP routing so that you can have protocols again with some changes. Now I would like to run EIGRP on this 3 router. Right now there is no routing protocol, so show IP EIGRP neighbor, no neighbor, show IP route, EIGRP, no routes learned via EIGRP. I'm going to say router EIGRP autonomous system 100. The networks. I don't know the networks on this interface. Let me go and check. Do show. So when do you put do command? Whenever you're typing show in some other mode other than privilege mode. All the show commands works in this type of privilege mode. The privilege mode. But right now I'm in the routed mode. Router EIGRP mode. If I need to use the show commands, then I need to put do show. Simply if you type show, it won't come. Do show IP interface brief. I see there are 10 networks. And then I see a loopback, one network. So all that I need to do is I need to say network 1000 network. So when I say 1000, EIGRP will start running on both these two interfaces because both the interfaces have got 10 in the first octet. Right. Let us verify. How do you know whether EIGRP runs on this 3 interface? What are those 3 interfaces? 2 physical and that one loopback. How do we know? The command is show IP EIGRP interface. Boom. So you got 3 interfaces. Under EIGRP autonomous system 100. I'll repeat the same on router 2 and 3. Router EIGRP 100. Network is 2.0.0.0. And I'm expecting a neighbor between, it's already there, between 2 and 1. This is the IP address of .1.1. The command to verify show IP EIGRP neighbor. Now, what is this? This is the timer. 11, 10, 14. After 10, it turns to 14. You know why? Because every 5 seconds we get the hello. This is a good sign. You're getting hello, that's why it gets resetted to 14. So it's a countdown timer. When it reaches 0, the neighbor will be considered as dead and this will be removed from the routing table. These are all not that serious important thing like round trip, time taken for these 2 routers to send and receive some response. It takes this many milliseconds. This is also something related to same round trip. Now let us go to router 3 and configure EIGRP. Router EIGRP 100, network is 3000, network is 10000. Again we'll find neighbor is 10 already. So R3 and R2 are not direct neighbors, neither indirect neighbor, but R3 knows about R2 via R1. When you type show IP route EIGRP, I should see 2.2.2.2 via 10.13.01, which is router 1. So we will be able to ping now from 2.2.2.2. And I'm going to source it with 33333. which means my source IP address of the packet is 33333. Destination IP address of the packet is going to be 22222. If I'll see a response, what does that mean? It means that router which has got the 2222 is also able to reach 3.3.3.3. Otherwise, the response won't come. If router 2 don't have 3.3.3.3 in its routing table, can it respond me back? No. So instead of going to router 2 and checking whether I can ping 3333, you can also ping like this. If you'll get a response from 3333, I'm pinging with this source. So this will become the destination on all this response packet, which means R2 can reach the destination. If you check the routing table, show IP route, you have the route. So you don't need to come here and check this. You can check this by pinging like this. If you can get a response, which means router 2 can also reach router 3's loopback. Now, right now, EIGRP is done, but without authentication, not safe. If someone brings their router and assume that there is a layer 2 switch in the middle. Someone brings a router and say my IP address is 10.13.0.8 and EIGRP autonomous system 100. That someone also will become neighbor to R1 and R3. And all the routes of our internal network, our company, will be revealed to that route. Not only that, if that someone wants to push some fake routes for his own benefit, he can do that. If BGP sends an update, R1 and R, sorry, no, if EIGRP sends an update from that someone's router, if you receive an update, your router is going to receive, accept, process it, update it into the routing table. So there are chances of that someone diverting our traffic to a wrong direction for his own benefit. To avoid such attacks, that's an attack actually. To avoid such attacks, we need to enable authentication so that before accepting anyone as a neighbor, authentication will be done. The identity of the incomer will be verified. Let's do MD5 authentication. The only authentication that EIGRP supports is MD5, no plain text. Because plain text authentication, at any point, any time, someone can use a Wireshark over this wire and know the password and use that password and form the neighbor. It's easily available by using simple tools like Wireshark. The password will be easily visible, revealed. So when you encrypt and send, only the encrypted hash value will be revealed. With that, no one can make out the real password. So what we are going to do now is authentication. It needs a keychain. I go to R1. Key chain. Give any name. I'm going to say key chain underscore 1, 2, 3. It's between row 1, 2, and 3. Key ID 1. First key. The first key string is, means the password is Cisco 123. And I'm not saying any lifetime. If I don't say any lifetime, it's forever. From now it will start forever. So let's do this first. And now I'm going to assign this under the interfaces. Interface range, because I want to assign this keychain on both the interface, I can use the range command, but not all operating system will support this range command. Switches, all switches will support this range command, but the routers, not all operating system. Version 15 and above supports this. Range G3/0, G4/0. And I'm going to say IP authentication for what? For IP authentication mode for EIGRP 100. I want MD5. See, as soon as I put that mode MD5 from null, the authentication mode is changed to MD5. As a result, the neighbors all are going down because the neighbors were not enabled with authentication. They are not enabled. IP authentication, after mode comes what? Keychain. For EIGRP 100, I said keychain underscore 123. Oh. Now the authentication is enabled. If you go now and check the packet, I'm going to sniff some packet and show you. The hello packets that are sent from R1 will have authentication. See, from R1, there is an EIGRP hello packet. There's a hello packet. You see, authentication is MD5. And if you go down, you will see the message digest. This is the password. The password that we actually put is Cisco123. What do you see? It is a hash of Cisco123. No one can understand this. Only those routers which belong to same autonomous system, same password, same key ID. Key ID is also sent. Only those routers can understand this. But when I check the hello packet from router 2, there is no authentication. See, there is nowhere mentioned about authentication. Let me click. When I click from router 1, you see authentication. After autonomous system number, I have authentication. Whereas from router 2, after autonomous system number, you don't have authentication. One more time. After autonomous system authentication. Yeah, this is from router 1, 10.12.01. From router 2, after autonomous system, there is no authentication. Let's go to router 2 and enable authentication. So right now, if you see the routing table, there is no route from EIGRP, no routes from EIGRP. Interface G3/0 here, just one interface, so I am not using range command. And I say, oh, we need to put the keychain. I'm going to copy the keychain from there and paste it. Show run. Just show run. It will be there on the top. This is it. This is the new authentication keychain that we want. The old one, I don't care. There are some other authentication keychains which I enabled on the previous patches. That didn't get removed because that is common. It's not only for EIGRP, it can also be used by routing protocol RIP. So when I removed EIGRP, The keychains are not getting removed because they're not binded with EIGRP anymore. So I don't need to worry about that C1 and the FR3. I just want this 3 line which is highlighted here. I copied it. I go to router 2, paste the keychain, and apply that onto the interface. Interface G3/0. IP authentication mode for EIGRP 100 is MD5. IP authentication keychain for EIGRP 100 is keychain underscore 123. Now I'm expecting neighbor. Neighbor has come. And I'm expecting route 100, Yes, we have learned. And now if you go back to Wireshark, you will see between 1 also we have authentication message digest. And on route 2 also we have authentication message digest. Both 1 and 2 has got authentication message. Let's stop this debug. Wait, I repeat again. No, see this 10/12/01 and you got a message digest. See the last phone number EB5E. And now 10/12/02. And it is not EB5. But the password that we used is both. On both, it's the same thing. The password that we used on both the side is the same thing. Then how is this not matching? Of course, it should not match. It will not match, and it should not match. That is why we called it hash. Hash value. So even the encrypted password is not sent. The hash of it, using some algorithm, it generates hash. That is what sent. The receiving router will also take this hash and use that same MD5 to understand the original password. So it works on both sides, even though the digest doesn't match. For the same password, you got different digest. It's okay. Not it's okay, it is good. It should not match. Yeah, that's taken care by the algorithm, the encryption decryption algorithm. Now, I would like to close this. Between 1 and 3, there is no neighborship. There's only one neighbor. So let us go and configure on R3. In the same keychain I want. So show run. This is then I go under interface G3/0 IP authentication EIGR IP authentication mode is for EIGRP 100 is MD5. IP authentication keychain for EIGRP 100 is KC. 1, 2, 3. The neighbor is going to be, okay, we got it. Optionally, you can say multiple passwords with different time ranges. Let's see how to do that. Right now, it's forever. The authentication is forever. Show IP EIGRP interface G3/0 detail, no detail. Okay, but authentication is enabled and the lifetime of the password is forever. But I'm going to say no. Key chain KC_123. Oh, no. It creates a new key chain. It's underscore. Key string is one we gave. Now I can say that Cisco123, the key string that we gave, Cisco123, the key string that we gave, I want to send from now. So you have various options. Time starting from, or I can say copy the time from my router. Router is good clock. Do show clock. See the time. According to my router, this is the time. UTC time. Wednesday, 23, May 24. I say no. Wait, let me give you. Send lifetime from 6 a.m. of 24th May 2023 till when? Stop time, you can say that. Or you can say infinite. Or you can say duration in seconds. So after that, this password will not be sent in the hello packets, and the other router will reject this router because the hello packets are not having authentication. If they need to accept, then they also need to stop using that password. Yeah. So there is also another command called accept lifetime. How long I will accept. Same way, you can say timing. How long I'll accept that Cisco123 SMS. So this, what we can do is, we can have many passwords and we can give different time period and we'll overlap the time. Say for example, I'll say the first password will be valid till this Sunday 28th early morning 1 o'clock. And the second password will become active the same 28th early morning 12 o'clock itself. So during this 1 hour, 12 to 1 in the midnight in the early morning, both the passwords will be active. We need to overlap. The reason is there may be some slight time difference between the router, 1 or 2 seconds or 1 minute or 2 minutes. It is always good to overlap so that there won't be any break, neighbor lost. There won't be any route lost. When neighbor is lost, route will get lost. When will the neighbor be lost? When the authentication is mismatching. All right, but again, using keychain is an option, not the mandatory one. Not many people use it. That you can try, you can give like 1 minute, send and receive lifetime, accept lifetime, send lifetime, 1 minute. On the other router also you do the same thing. After 1 minute, you see what happens. Then try to give another key ID 2, key string Juniper 123 as a password, key ID 3, Huawei 123 as a password. Try as a homework, right? Will you be able to do this? Can you do this as a homework? Yeah, try to use accept lifetime, send lifetime. Okay, so let us go back to our presentation and continue our learning. The enterprises now, we will have many routers, many routers,
Yes,
because
sir.
we got many subnets and many buildings inside the campus, many floors, many departments. So to connect all these different layer 3 domains, different layer 3s, why I call it as different layer 3 domain, because we got different subnets, we'll need many routers. And we use a routing protocol like EIGRP to distribute the route information so that one router will know the location of other networks. When we use a protocol, the protocol should be friendly. The protocol should not be a burden, rather it needs to be friendly. Now, what do we mean by burden? For example, if any change happens, if the change will impact all routers, then every connected devices to the router will also get that impact. A small change that happens should not impact the whole autonomous system. It will become a burden for the network. Why? All the routers need to recalculate, resynchronize with the change that's with an update that come in to all. This is going to be a disruptive one. So when a change happens, the change may impact the very next router, but not the whole autonomous system. If I have 20 routers as after me, after my router, 20 other routers connected one after the other. If all 20 will get impact because of one small network going down in my router, that's not good. It cannot impact that depth of the topology. Maybe 1 or 2 hops may get impact, not 20 hops. Those routers which is getting impacted may not consider this as a serious change, but still there is an impact though the change that happened is not that serious for the other routers. Of course, there is a change. The impact is there, but not for the entire autonomous system, a local impact. Then the disturbance also should not be throughout the autonomous system, it needs to be local. For example, if I lost a cat in my home, it can affect my family member. That's all. Within a compound, yes, my child will be very sad. Oh, daddy, what is this? She'll cry. And I will also feel sad because every day morning it comes meow meow, always next to me, coming close to me, talking to me, and all of a sudden it is silent. But it should not impact my neighbor. For them, it is irrelevant. It will not be really uh, they will not be willing to hear this. For them, it's not their business. It's not their cat. Likewise, EIGRP flooding the change to everyone in the autonomous system is not good. It's unnecessary disturbance cost. It can impact maybe very next router, not more than that. But there are some changes which need to be updated to all. But small subnets should not impact the whole autonomous system. That small subnet which has gone down may not be a network which everyone visits often. So we need to control such bad impacts caused by EIGRP. Two ways in doing this. One, summarization. Two, stub. You can use any one of this to avoid such bad impacts, unnecessary impacts, disturbing depth of technology and so on. The factors that influence the scalability of this protocol, EIGRP, is number one, quality of routing information exchange between peer. Sorry, not quality, quantity. No summarization, then the quantity is going to be more. If I got 100 network subnets, I can summarize it to one subnet, or I can route it to classful boundaries using summarization. Then the quantity of routing information exchange will be just one, not 100. Opposite, when we don't do summarization, it's going to be excessive, too much. So that's one thing that impacts, that influence the scalability of EIGRP. It's any excessive amount of route information. So when you see there's excessive, you do something. One of the things that you can do is summarization. Second point, the number of routers that must be involved when a topology change occurs. So when a topology change occurs, how many routers are involved? That also impacts the scalability of the autonomous system. Needs to be as low as possible so that the scalability will be good. Right. Third point, depth of topology, meaning the number of hops that the information must travel to reach all the routers. So if you want to send an update, how many routers it needs to travel? That also will influence the scalability. This also number of hops that information must travel also need to be as low as possible. Fourth way, number of alternate paths through the network. If you have more alternate paths, it's going to be highly scalable. rather than keeping only one path. And you don't have alternate path. I mean, physically you may have alternate path, but because they did not satisfy the alternate paths that which are there did not satisfy the feasibility condition. The advertised distances are not less than the successor value. Then also there will be an impact in scalability. Why? That's what this chapter is going to be. How the scalability will be influenced if you don't have an alternate path. Physically, you won't have an alternate path because that doesn't satisfy the feasibility condition. Now this is that story. EIGRP will send a query when a route is lost and when there is no feasible successor available. So we have different message types. Hello packet, update packet, query packet is also there. Query. When will the query send? The query will be sent only if there is no backup path. And the primary path that you had is lost already. So we got many neighbors. But for a destination, you don't have path via all the neighbor. There is only one neighbor via which you were forwarding the packet, which means only feasible. So there is only success, there is no feasible success at all. But topology says there are multiple backup paths. The physical topology says there are chance of having alternate route to reach the destination. The EIGRP says no, I got only one. So what will happen when the route is lost? It will be sent to other neighbors asking for the lost route. So for the destination to which the route is down, query will be sent asking for another route to the neighbors. Query will be sent to other neighbors asking for any available routes to reach the destination. And this query will be sent to all the neighbors that are connected to all of the interfaces except that interface which was used till now as a successor route. For example, you see this picture. This is a successor route from B via B to this destination. This direction query not go to regional office direction. When this is lost, the query will be sent to all other neighbors. It will go to A, it will go to C, it will go to D, it will go to E. And those routers will not keep it for themselves. They will send it to their neighbor. So whatever C received from B as a query, now C will also forward it to its neighbor. So it goes to A again. A has already received from B, but A receives also from C. And A will forward it to B back. Because it is not received from B, it is received from C. Originally it is sent from B, but A has received from C, it will forward to B. Whatever A received from B, it will forward to C. So there's going to be a duplication and loop and a big mess. Save update, see how many arrow marks. Just one small query. See how many arrow marks there in the page. That many times the query has been duplicated. And this won't stop, this will keep increasing. The query is sent in this hub and spoke topology like this, which has got a very bad impact. It really spoils the scalability. Now, what if the neighbor also do not know the route? See, the query is sent to everyone and every neighbor is forwarding to all other neighbor. Why? Because they don't know. When C received the query, C did not respond to B. Why? Because C also don't know. So C forwards the query to its neighbor, which is A. A forwards the query to D and E and B. Likewise, every router will forward the query, but originally it was sent from B. Query is now flooded everywhere because they don't know, so they keep flooding to other links, hoping that the other neighbor may know. So if the neighbor do not have the lost route information, queries are sent to their neighbor. So what if there is no one knows about that network? The query will be still going. And then what will happen? All the neighbor who has not responded to the query will be removed from the neighbor list. Yes. So it's not there in the page. I'm just telling what is coming in the next few pages. When query is sent to neighbors, and if the neighbors do not have answers for the query, they forward it to their neighbors. And the one who sent the query will be waiting for 3 minutes, hoping that I sent a query, he will give me. I sent a query, he will give me. Everyone is now waiting. Every router has forwarded the query to their neighbor. They're all waiting. After 3 minutes of wait, they understand that neighbors might have been dead. That's a wrong understanding. Neighbors are still sending hello packet every 5 seconds. But because the query has not been answered by the neighbor, I'm going to remove all those neighbors who did not answer my query from the neighbor list. Yes. It will remove the neighbors who did not respond to the query. Now, just imagine every router, every hop was forwarding the query to all other neighbors, their neighbors, to their neighbors. And now every router is going to remove the adjacent router from the neighbor list because they did not respond by sending reply. If someone might have responded, that's the last point. If the router has an alternate path, it answers the query. This stops the query from spreading in that branch. But there are other branches. You might maybe E may have some answer. It may respond back to B, but the query which is sent via D and C and A will be still going. It is not stopped in that branch like C and D and A. Only E has got the route, backup route to reach that lost route. So E is going to respond to B. That's what here we see. If the route has if the adjacent router which received the query has an alternate route, it is going to respond to the query. It is going to answer the query. So this response to the query stops spreading the query in that branch of the network. Now, who responded? Assume E responded, saying, "Hey B, don't worry, I know the route, come through me." E says that, but B will not use it. Even though E is giving a reply to the query, B will not use it. Why? Because B has also queried the other neighbors like E, D, and A. So what I was telling is, even if you get response from one of the neighbor, see B has queried 4 neighbors, but only one neighbor responds. Let's say E responds to B. B cannot use it. The reason is it has also queried the other 3. So B have to wait for other 3 also to respond, but the other 3 cannot respond because they are not connected to the destination in any way. As a result, B cannot use the route given by E until it discards the neighbors C, D, and A. It needs to remove the neighbors C, D, and A which did not respond. Only then the route given by E can be used. That is the reason why it discards, so that E's route can be used. After which C, D, and A will rejoin. So the reason why B is removing C, D, and A from the neighbor list is because C, D, and A has not responded the query. In order to use E response, either C, D, and A should give some response or they should die. They should be removed from the neighbor list. That's the procedure. Only if it is removed, the answer given by the response given by E can be used. Or all should respond. So the neighbor C, D, and A, because they are not connected anyway to the destination, they're not going to respond. In order to use E's response, B is going to remove C, D, and A from the neighbor list and start using the route given by E. After this, the neighborship between B and C, B and D, B and A comes back by sending hello packet. So this chaos that happens should be avoided. So we are trying to understand the influence, the scalability. In that, what we are seeing is we need to control this query because this query is going too deep in all directions. When a query is received, all the neighbor routers will forward it via all other to other neighbors via all other via all interfaces that they got. And when someone responds to the query response cannot be used immediately till everyone responds. If someone is not responding for 3 minutes, the neighbor will be removed so that the response that has come from one particular neighbor can be used. Now, this is a big mess. This is the one, that has a depth of the topology. Number of routers involved when the change occurs are too many. There are too many alternate paths. Some may not be an alternate path. Few may be an alternate path. So this is getting stuck for a period of 3 minutes at least when there's a change happens, when there is no feasible successor, and the active route goes down. This mess happens always. So to avoid this mess, we need EIGRP stub. You see, the problem might have been solved if the router would have responded. When B lost the primary route, it started querying A, C, D, and E. If A, C, D, and E, if they give some response, I don't know. That is also a good response. I don't know. Or I know it. Some sort of response, there won't be any problem. Because these routers are not responding, they are simply forwarding the queries to their neighbors. This problem occurred. So configuring the router to send a special information, peer information, is what called a stub. So when a query comes, this router will immediately answer, sorry, don't come to me, I don't know. Problem solved. No, not like that. Actually, when you configure the router as a stub router, before problem starts, they will go and tell, hey, see, these are the things you can expect from me. Other than this, don't ask me anything. So there won't be consent. See, beforehand, if router C, D, and E, and A, C, D, E, and A, before this problem started, if C, D, E, and A would have told B that I know only these many things, don't ask me other than this. If it would have told this thing beforehand to B, B would have not sent a query. And this problem might have not come. Yes. Configuring C, D, E, and A stub, EIGRP stub, makes this router to go and tell to B beforehand what it can do and what it cannot do. See, let's read these lines. EIGRP stub routing feature improves the network stability, reduces resource utilization, and simplifies remote router configuration. How? Stub routing is commonly used in the hub and spoke topology. Point 3. The stub router sends a special peer information packet to all the neighbor router, reporting its status as a stub router. Meaning, when you configure C, D, E, and A as a stub router, this router will go and tell to B, these routers will go and tell to B that, hey B, these are the networks I have. Other than this, I don't have any other. Don't come to me. Don't ask me other than what I'm giving. So it is just revealing that I cannot send to any of my other neighbor. So don't trust me. Whatever I give you, you use. For other things, don't send to me because I'm a stub router. I will not be forwarding to my neighbor. I'm a stub router. I will not be forwarding to my neighbor. I'm not responsible for those things. Sorry, don't come to me. This is what we call as stub router, sending a special peer information packet. A neighbor that receives a packet informing it of a stub status does not query the stub router for any routes. This solves the problem. Now there are 5 different types of stub: receive only, connected, static, summary, and default. I think we should see this in our next class, right?